Now we're starting the last topic that will be on the final exam. So there may be some new topics coming after this, but they're not going to be assessed on the final exam. So now we're going to talk about repeating with whiles. So far we've looked at for loops. They have been our major vehicle or mechanism for repeating lines of code, repeating statements. So there's another way that we can repeat statements using while loops, a different type of loop. To summarize, whiles are like if statements that repeat. So if you want to stop watching the video there, that's fine. But if you want to see more, carry on. Okay, so let's figure out the difference between while loops and ifs and for loops, because while loops and for loops can implement some of the same things, and you might want to use a while loop sometimes and a for loop at other times. And I already said that while loops are kind of like ifs that repeat. So let's look at these three examples. So we've got a while, so we've got count equals 0 as a variable. While count is less than 10, we're printing out count and we're incrementing it. Here we're saying count equals 0. If the count is less than 10, we're printing count and we're incrementing count by 1. Okay, so the while loop, if you could take a wild guess at it, the while loop is going to output the numbers from 0 through 9. Unlike the while loop, the if statement is only going to ever execute these lines once. So ifs are like while loops where we only execute them once. And ifs can also have else and elifs, which whiles cannot have. So this if statement is going to only output 0. And it's going to keep going. There's no while repeat, and it doesn't continue onward. The value of count, however, the variable count, will be at 1 after this. But we're only printing out 0. We're not printing out all the numbers. Okay, so that's the major difference between while and if. Now, if it helps to look at something familiar, a for loop that also outputs 0 through 9 would be written this way. For count in range 10, print count. So the output we see over here is true for both the while and the for. So why do we need another way to repeat? Is there some reason that we use while loops? They were kind of a little bit longer than for loops. Well, when we have a repetitive task, it's good to repeat it in code because it's more efficient and it's more dry. So let's think about this for a minute. Which of these tasks can we use a for loop for? So shoveling snow or raking leaves, we probably know in advance how many leaves we have, but maybe we don't know how much snow. Putting a case of beverages in the fridge one at a time, we can probably use a for loop because we know how many cans there are. Waiting for an internet release time, we don't know exactly when things will be released, so that might be a case for a while loop. Same with checking texts or status updates. Moving something around the screen, we probably know exactly how far we want it to go. And folding socks, you could go either way there. If you know how many socks you have, you can use a for loop. If you don't know how many socks you have, then you'd have to use a while loop. And so I'm hoping that you're starting to see the trend that a for loop can only be used when we know in advance how many times it's going to execute. So if we don't know in advance how many times something will execute, then we need to use a while. So for instance, a lot of times loops that are used in conjunction with user input are often whiles because you never know how many times a user is going to do something. Okay, so we did look at while versus for. What I want to emphasize here is that any for loop can be written as a while loop. So while loops are more general than for loops. They're more powerful. They can be used in more situations than for loops. So for example, any definite loop. This is a loop where we know in advance how many times it will execute. Any definite loop can be written as a while or a for. And down below we have two examples, two code examples, one using while, one using for, both of which output the exact same thing. So the first step is identifying any differences between these loops. So in the while loop on the left, the treatment of the variable I is very explicit. We're initializing it to 0 while I is less than 10, and then we're adding 1 to it each time. In the for loop, for I in range 10, you have to know the semantics of range and the semantics of the for loop itself to understand that what's happening to variable I is in essence happening over on the right-hand side in the for loop. The other difference is that at the end of the while loop, I can print out done and I'm going to get 10, but if I want to get 10 on the right-hand side, I have to add 1 to it. So because at the end of the while loop, you have to increase the loop variable. So I is the loop variable in both cases. You have to increase the value of the loop variable so it breaks the condition I less than 10. So at the end of the while loop, our loop variable is actually going to have a different value from our for loop. So there are some advantages and disadvantages. For definite loops, so this is when we know in advance how many times something will execute. Usually, more experienced programmers use a for loop. Now, as novice programmers, presumably novice programmers, it's possible that you might actually think that the while loop is easier to understand for you because it's making everything explicit. It's making the I equals 0, the condition I less than 10, and the increment I plus equals 1. It's making those all very explicit. You can see them in the code, whereas a for loop hides some things. The semantics must be known in advance. And so typically novice programmers may find either one of these easier to understand. And it doesn't matter to me as long as you tend to use the one that you find useful. Once experienced programmers understand and internalize what a loop means, they tend to favor the for loop. But really, it's apples to oranges, whatever you prefer. One advantage of the for loop is that it's shorter, it's more concise, and so it's also a little bit more readable. And so from a more expert programming perspective, many experts prefer the for loop for those reasons. Now let's take a look at a different type of while loop. Count equals 1. While count is greater than 0, print count. Count plus equals 1. So this is going to output, actually, in fact, maybe we can, let's see what this outputs. Okay, so we are trying to output, let me make this big enough that you guys can see it. All right, let's see. So count equals 1. While count is greater than 0. Whoops. Okay, I want to forget my colon. Print count. Oh, I didn't indent. This is what I get. Print count. Count plus equals 1. Ooh. What's happening? Is this ever going to stop? Is this going to go on forever? I could sit here and watch how big integers are because it'll start repeating once I've reached the end of the size of an integer, but let's not take the time to do that right now. Okay, so let's get back. Okay, so this is what's called an infinite loop. It's never going to stop. So the problem is that our initial value of count is 1, and we have while count is greater than 0. Well, guess what? Our variable already meets the requirements, the criteria for the condition for the loop to continue, and then we're increasing count by 1 every time. This would actually work if we were decreasing the value of count. So the idea is that the relationship between what you initialize your loop variable to be and the condition and the step all have to lead towards the condition becoming false. So you start with the condition being true and you have some relationship between this initial start value, the condition, and the ending value, the step value, excuse me, that all relates and goes towards one another. So if you start at something, you want to go towards something else. In this case, the condition will never be false, so we keep executing the loop again and again. There's a couple ways if you find you've created an infinite loop. This wasn't possible with for loops. For loops are definite. They have to end. We have to know in advance how many times they will execute. We didn't have to deal with infinite loops. But if you find yourself with an infinite loop, the way you can stop your program on the command line would be Control-C or Command-C if you're on a Mac, or you can press the stop button in PyCharm. Just as a fun note, Apple computer is located, their mailing address is one infinite loop. So the question I have for you is that in the example we just saw, an infinite loop is not desirable. We did not want a program that went on forever. Is there ever a time when we do? Well, there's certain types of software that we always want running. For example, every phone and computer has an operating system. You might have the Mac operating system or a Windows operating system, typically on a laptop or a desktop computer. Well, do you ever want that to stop running? No, you want it running all the time. So sometimes in certain applications, especially ones that handle user input, so an operating system is waiting for a user to tell it what to do. A web server, for example, is waiting to service web requests and deliver pages on the internet to you. And so anytime that a service is waiting for external input, often uses infinite loops. And so here's an example from web servers. While true, listen for request, handle request. So this is an infinite loop that's intentionally put in here with the code. Now the next question is, can a computer automatically detect infinite loops? And the answer is no. It's what's known as an undecidable problem. So there are problems in computer science that cannot be solved by a computer, only a human. This is one of them. So our best practice is to prevent infinite loops. And so in a case where we could use a for loop, often we should because it helps protect us against infinite loops. One other thing I'd like to share with you is another way that we can use while loops. And this is the alternative to a definite loop. And we have an indefinite loop, so we don't know how many times in advance that a program will run. We can use what's called a sentinel value or a sentinel loop. And in this case, this sentinel, it's kind of like a soldier who's guarding something, guards entering the loop for us. And this often happens when we don't know in advance how many times something is going to run, but we're going to loop until some condition is met. So in this case, we would initialize a value. While that value doesn't equal the sentinel value, we process the value and get the next value. So we update the value in some way. Okay, and in this example, we will see this template, this design pattern of a sentinel loop used in some of the assignments, some of the practice exercises.